Hey guys, so the LeetCode problem we'll be solving today is longest increase in subsequence. So the problem says given an integer array nums, return the length of the longest strictly increasing subsequence. So a subsequence is an array that is derived from another array by deleting elements while still maintaining the order of elements. So I'm going to use an example to further elaborate on this. So for this array of nums, which has elements 1, 3, 2, 4, the subsequence is 1, 3, 4 because we deleted the second element, the third element in the array while maintaining the order. But 2, 3 is not a subsequence because if we delete 1 and 4, we get 3, 2. And in order for us to get this, we need to switch the order in the order in which elements occur, which is 2, 3. So now, for the longest increasing subsequence problem, we need to find the longest increasing subsequence at each level in the array and basically add one to it. So let me explain what I mean by that. So let's say we start from the number 1. We try to find the longest increasing subsequence at point 1, starting from point 1. So starting from point 1, we can go to 3, 2, or 4 because these values are greater than 1. And if we go down the path of this part in which we have 1 and 3, the only possible value we can go to after 1, 3 is going to be 4 because 3 is greater than 2 and that's not increasing. So the length of this is going to be 3. But the way the solution is built up is that is first going to find the longest increasing subsequence starting from the bottom. So the longest increasing subsequence starting from the bottom is going to be 1. So once that's gotten to this base case or this bottom part, is going to now go up, and we're not going to have 1 plus the longest increasing subsequence at this point, which is also 1. 1 plus 1, which is going to be 2. And the same thing happens here. But for this point, the maximum longest increasing subsequence is going to be 1. So now we take the maximum from this level, which is going to be 2. So since the maximum from this level is going to be 2, the longest increasing subsequence starting from here is going to be 1 at first. But now we know we have traversed this part and we're going to pick the maximum from here, which is going to be 1 plus 2. So yeah, so that is the same algorithm which was used for here is going to be used for all these parts to get the longest increasing subsequence. Yeah. So now I would like to code up the solution. So for this, we are going to first create a copy of the array because I don't want to pass it into the function. So it's going to be this.nums is going to be equals to nums. And then we're going to have a DFS function in which is going to return an integer. What we pass is the int start, the starting position, and the beginning we have int max lis is going to be always equals to 1 because at the beginning of each position the maximum longest increasing subsequence is going to be 1. So we need to go for int I equals to start I plus plus I less than nums dot length I plus plus. But first gonna check if the starting position, which is num start, is less than the next position. Yeah, which is going to be nums I. If it is, we're going to have an int depth here, int lis. Let's call it lis. Let's make it okay. No, let's call it lis. Is going to be equals to dfs start No, not DFS start, DFS I actually, plus 1. Yeah, then after that we use max lis is going to be equals to math dot max lis comma max lis, and each point after this we're going to return the max lis. And then the way the function is called, since we can start from any point, we're going to have int I equals to 0, comma I less than nums dot length I plus plus, and then we're going to have int lis is going to be equals to dfs I. Then we're going to select the we need a variable. Can be going to have a max lis here too, which is local to this point, and max lis is also going to be 1. It's also going to be equals to 1. Then we're going to get the max lis, which is going to be equals to math dot max lis comma max lis. Yeah, we're going to return the maximum lis here. Run. I need to be consistent with the naming. Just name it Elias, to be honest. Yeah, so we can see it passes all the test cases. If we submit it, though, it won't pass all of them because the session is a bit too slow because we're doing repeated work. So if I submit it, yeah, time limit exceeded. So in order to speed up the solution, we need to use memoization. So we're going to say private I'm going to use an integer plus I'm going to have temp. I'll call it a store. I'll call it memo actually. Memoization. So what we're going to do is that the memo, so this dot memo is going to be equals to new integer nums dot length. Yeah, so that's okay. So we're going to store memo start, the value of max lis at each point when it occurs, so we avoid doing repeated work. And so we're going to check if memo start is not equals to null. We are going to return memo start to save time rather than going through all the possibilities again. And what else? So let's run it. Still passes, submit, and all test cases are passed. And yeah, so I think yeah.